let's pick up where we left off yesterday or the day before, whenever that was. What were we talking about? Does anybody remember? Sequences, right? And we said, well, we could make up any kind of random numbers for sure. There are two special kinds, arithmetic and geometric. And Olivia, what are you doing? Sorry. And Matthew, why do you have these things for your ears? Take them out. What's the difference between an arithmetic sequence and a geometric sequence?
You add and
in one you add to get from term to term, and you don't just add, but you add the same number. And the other one you multiply by the same number. Which is which? Arithmetic add. And we can remember that because arithmetic add. It goes start with A's, right? So, okay, what are we going to do today? Well, let's look at problem number 2. It says find the first 4 terms and the 70th term of this sequence. Now, do not be confused by the notation. N is a counting number. 1, 2, 3, 4, 5. We call those natural numbers. So B sub 1, I'm going to let N be 1. So then my equation would say what? If I let N be 1, B sub 1 equals 6 over 1, which is 6. This is the notation for the first term. When you put that little subscript on there, that means that's the term number. So B sub N, or B sub 1, is the first term of this B sequence. This sequence is named B. And the first term of the B's is 6. All right, what's the second term of the B's? Well, now we're letting N be 2, right? So what is it? 6 over 2, it's 3, exactly. So see if you can fill in, they want 3, B sub 3, B sub 4, and then B sub 70. See if you can fill those in. If you're letting N be 3, then just let N be 3. And then let N be 4 and let N be 70. What'd you come up with for B sub 3? 2? Anybody get B sub 4? 1.5 or 3 halves. Either way, doesn't matter. Whatever way you
on a test,
like it best.
On a test, will it matter? Or
I just got done saying it doesn't matter. B sub 70.
I got 0.085.
Well, let's not do that unless it's
Okay.
finite. 1.5 is not rounded off, so it's okay. But if we're going to come up with a decimal, we have to round off. Let's leave it as a fraction. So that would be 6/70, which is 3 over 35. There is your best answer. We don't want to round off. If you can write a decimal and it doesn't round off, fine. But don't round it off. All right, now let's look at our C sequence. This sequence is named C. Oh, by the way, let me write out this set of numbers. We had 6, 3, 2, 1.5, and 3/35. Well, actually, that one doesn't really count because that's down the line a ways, right? Is this sequence of numbers that you generated, the first term, the second term, the third term, and so on, does it appear to be arithmetic or geometric? I think this is a neither. Because to get from here to here, we would multiply by a half. But we don't multiply by a half to get here. So it's not geometric or arithmetic. It's just a random set of numbers. This one I think is going to be special, though. What's the first term?
Three.
Now be careful, what do? You're letting n be 1. So if you put a 1 in here, what do you get? You get 3? Right, now put a 2 in. That's what this says. Let n be 2. 5. How about 3? Uh-oh, something's happening here. And then what would the 70th one be? 141. What kind of sequence is this? 3, 5, 7, 9. Now remember, there's a whole bunch in there, so don't really count that one. But 3, 5, 7, 9, that's arithmetic, isn't it? That's an arithmetic sequence. Okay. And for the following arithmetic sequences, find the common difference. We'll stop right there. You all can do that. What's the common difference? How are we getting from term to term? I'm talking about in 3A. 3A. Subtracting 4. So the common difference is -4. We're adding -4. Now, could you find the 8th term? Well, sure you could, but what would you have to do to find the 8th term? Just keep going, -4, -4, -4, -4. And 8 isn't that many. That would not be a big deal. But what if it said 80th? Or like these problems, it said 70th. That would be a pain in the butt, wouldn't it? To write all that out. So I'm going to show you the shortcut now. We're going to kind of work on it together a little bit. To see if it makes sense to you. So the sequence is 3, -1, -5, and so on. Okay? You told me that I'm getting from term to term by subtracting 4 or adding -4. So the first term was 3. Call it A sub 1. That's the first term. The second term was 3 plus -4. That's how you got -1. Right? The next term was the 3 plus -4 plus another -4. So basically we took 3 and added 2 -4s to it. Well, what would I do for the fourth term? Would I add another -4? So instead of 3 plus 2 -4s, it's going to be 3 plus 3 -4s. We'll do one more. What would the next one be? 3 plus 4 -4s. Now I want you to notice something here. Is there a relationship between this number, which is the term number, the fourth term, is the relationship between that number and the number of -4s we have? So that number, and there's how many -4s I have. Even up here, I didn't have any -4s for the first term. Do you see the relationship there? Isn't that number one more than the number of -4s? So in other words, the nth term, okay, I've done the first, second, third, fourth, fifth. The nth term would be 3 plus n minus 1 -4s. Now look at that. Does that make sense to you? Do you see what I'm saying? This is logical. The fourth term was 3 plus 3 -4s. The fourth term, or excuse me, the fifth term was 3 plus 4 -4s. So the 8th term would be 3 plus 7 -4s. Right? So you wanted the 8th term, 3 plus 7 -4s. This number, the number of -4s, is 1 less than the term you're finding. So what is that, -25? Now, said, okay, whatever term I'm looking for is gonna be 3 plus 1 less negative 4s. Well, let's clean that up a little bit. 3 plus negative 4n plus 4. Or 7 minus 4n. So when the directions said, find a rule for the 8th term, or find the value of the 8th term, we did that. And then find an expression for a sub n, we did that. I don't know how you can possibly yawn during this. This is exciting stuff, Diana. Now, this formula works for this sequence. I wonder if we could expand the idea and do it with all arithmetic sequences, including, the ones that are coming up here. Let's look at this for a minute. Where'd this 3 come from?
First term.
That was the first term? That was the very first term in my sequence? So let's call it a sub 1. That's the first term, a sub 1. Then we have this n minus 1. What's that? Where did that negative 4 come from in this problem? That's what I kept adding. We call it the common difference. So I'll call it D. Write this down, guys. That's your formula for every arithmetic sequence. If the sequence is arithmetic, this will find your term. So let's make sure you understand what all these letters mean. There's lots of letters. This means the nth term. So if you wanted the 10th term, you would put a 10 in for n, a sub 10, 10th term. Then a sub 1, of course, stands for the first term. N minus 1 is just 1 less than that. So if you're doing a sub 10, then this would be 9. And D is the common difference. That's the number that you add to get from term to term. So when I look at the next problem, it says 10, 9.5, 9, and so on. Is this arithmetic?
Yes.
What's the difference, the common difference? Negative 0.5.
Yeah.
Aren't we going down? So my common difference is negative 0.5. The 8th term, according to my formula in the box, that works for every arithmetic sequence, the 8th term, put an 8 right there, is going to be the first term, which is 10, plus 8 minus 1, 7, times the common difference, which is negative 0.5. Okay, so type that on your calculator, 10 plus 7 times negative 0.5, and what is that, 6.5? Help me out, is that right? That's the 8th term. If I said to you, let's find the 80th term, you would do everything exactly the same. You would just put it in 80.
Is 7 coming from the other one, the other box?
The 7 is coming from this right here.
Oh, gotcha.
Because when we're finding the 8th term,
Oh, okay.
n is 8.
Yeah, okay.
So 8 minus 1 is 7.
Because it's one
Yeah, no,
minus.
it has nothing to do with, this is
Okay.
different.
Because it's one less than.
1 less than. Always 1 less than.
Gotcha.
Now, this is called the explicit formula. A sub n is the explicit formula. Well, it's right there. The first term is 10. n minus one is n minus one, because I don't have an n value, I just have an n. And then d is negative 0.5. Now, I want you to clean that up. What do I mean by that? What do we need to do? Distribute? So 10 minus 0.5n plus 0.5, did I distribute right there? I think so. So a sub n equals 10.5 minus 0.5n. Right? Okay, there's one more. It's exactly the same. Would you see if you can find the d, the 8th term, and the nth term for the sequence 10, 16, 22, 28? See how far you can get by yourselves, and we'll do it together. Out of here. This is our sequence right here. Is it arithmetic? How do you know? You're adding 6. That's your D, kids. Don't overthink it. That's your D. You're adding 6. And because it's arithmetic, you can use that formula right there.
Oh, so for D, you just put what you're doing.
D is the common difference.
Okay.
D is the number that we keep adding. That's D. So in this problem, it was negative 1/2.
Okay.
What did the 8th term look like for you? Well, let's go back. We're going to let n be 8, right? So then the first term is 10. Remember, a sub 1 is the first term, always. So we're going to start with 10. And then we're going to add n minus 1. Well, if n is 8, then what's n minus 1? 7. And you already told me my common difference was 6. So what's our answer? 52. Yep. So if you kept going with this set of numbers, if you kept adding 6, adding 6, adding 6, you'd get to 52 when you got to the 8th number. Olivia?
I'm sorry, I just want to know, how do you get the 7?
N is 8. So what's 8 minus 1? That's how you get it. All right, so did you get an explicit formula? Did you get an a sub n? What did you write down? A sub n equals? 10. Well, wait, you may have already simplified. I haven't. 10 plus n minus 1 times 6. So 10 plus 6n minus 6. So if you said 4 plus 6n, you are right. You are exactly right. Did I do that too fast? So some people already had it done. I was checking to see if they were right. So if you're walking down the street and somebody says, hey, what's the 100th term of this sequence? You can say, hey, the 100th term will be 604.
That's going to be really useful.
That is going to be useful.
Never.
Okay. Does somebody have a question? Uh-huh.
How did you get 6 and
Distribute. That's a
Oh,
distribute.
gotcha. I thought you were plugging the 6 back.
I'm not plugging anything in. That's a
Okay.
distribute.
Gotcha.
I'm just simplifying that expression. Yep.
Regular restaurant.
No, school's not in 8 minutes. Okay. All right. We got one more thing to talk about. And then we'll stop, and if there's time, we can let her go to the bathroom. If not, she'll just have to wait. Given the following terms of an arithmetic sequence, find the first term and the 100th term. All right. This could be one of the most tricky things we're doing in this unit. But you can do it, I promise. What this says is that the 4th term is 13 and the 7th term is 22. So you have a sequence, 1st term, 2nd term, 3rd term, 4th term's 13, 5th, 6th, 7th term is 22. You have a set of numbers that looks like that. And your job is to figure out what this is, and then to also figure out, if I kept going, what would be the 100th number in the list. You're told it's arithmetic, which means that the formula you're going to use is this one. That's your arithmetic formula. Now, Diana and Ethan were confused with the distributiveness. Feel free, if it's easier for you, to put the D in the front, because the D is what you're going to be distributing that number. So if it makes more sense to have it in the front, that's the same thing. Okay, so don't get confused. These can go in either order. All right, so that's the formula I'm using. Does anybody have an idea how we might proceed? Did you get your calculator? Okay, because he came in here looking for it. And we told him you were someplace else. All right, we got to get through this problem, guys. Here we go. What's your idea, Chloe?
Yeah, don't you have to phone
Don't I have to what?
out 3?
Okay, how did you figure that out? I don't know, Chloe. How did you figure that out?
60 and 19 and 73.
So how, what brought you to that? How did you get there?
Because I had to add or subtract, and they all have to be the same number.
Okay, so Chloe is just thinking about the problem, and she's saying, well, you told me it's arithmetic, which means I have to add the same number. So I'm trying to get her to tell me. I don't know if she was trial and error. I don't know how she figured it out.
I just picked a number and added
She
it.
just picked a number and started adding. So let's say we pick 5. Well, if I add 5, I get 18. And if I add 5, I get 23. So 5's the wrong number. So Chloe said, okay, maybe I'll try 3. If I add 3, I get 16. And then I get 19. And then I get 22. So by, I guess, guessing, Chloe came up with the common difference. She said the difference is 3. Now, if I add 3 to go this way, then how will I go backwards? Subtract 3. So this term would be 10 and 7 and 4. Okay, now, by guessing, Chloe figured out that here's 3, and this is 10, 7, and 4. So A sub 1 is 4. First term is 4. So when somebody says, okay, now find the 100th term, that is A sub 100, the 100th term, it will be the first term, which she figured out was 4, plus the common difference, which she figured out was 3, times n minus 1. What is n in this problem? N is 100. So n minus 1 will be 99. So then 3 times 99
297.
plus 4. What is that?
301.
301. So if you kept that going out to the 100th term, you get 301. Now, was anything about that uncomfortable for anyone?
You're just supposed to like guess.
Okay, you're just supposed to like guess. Well, if you're like Chloe and you're intuitive and you like to guess, that'll work. But we gotta come up with something better than that, because sometimes the common difference isn't a whole number like 3. Sometimes it's a number like 1/7. So next time we're together, we're gonna do problem B, but we're not gonna guess. Okay, it's okay to guess, it worked. But if we can't guess, we're gonna try, we need a new strategy.